In vibe coding, a single prompt can generate a complex, fully functional user interface without any traditional upfront architectural planning. But the polished, responsive dashboard rendered on the screen hides a highly fragile structural reality. The entire application is powered by a single 700-line HTML file. Inside this single document, the HTML structure, the raw CSS styling, and the procedural JavaScript logic are all combined. There is zero modularity. A senior engineer reviewing this file would immediately flag it. Without modern framework dependencies or a build step, it reads like the brittle, poorly planned code an AI is expected to produce. Evaluating the syntax reveals a binary split in logic. High-fidelity CSS rendering sitting on top of fundamentally flat JavaScript state management. This divergence matches the specific requirements of a single-page application scope, prioritizing immediate visual feedback over long-term maintainability. Auditing this exact 700-line file provides a blueprint of what AI utilizes in browser rendering and what it overlooks in software architecture. Effectively leveraging AI for production means identifying where it uses native browser efficiency and where it accumulates architectural debt. Looking at the style sheet, there is no Tailwind, no Bootstrap, and no Node build step. Importing a 50-kilobyte CSS framework to build a single dashboard view is an anti-pattern. Native browser APIs can achieve the exact same layout with a fraction of the payload. Instead of a rigid framework, the AI implements CSS Grid natively. It handles fluid responsiveness without media queries using one line. Grid template columns repeat auto-fit, min-max 200 pixels, 1 frit. Each card is guaranteed 200 pixels, and the grid mathematically recalculates the rest. This native solution requires 3 lines of code. It achieves the same outcome as applying utility classes across dozens of separate DOM elements. Without a framework compiler, the AI also has to build and manage a coherent design system from scratch. It does this by defining CSS custom properties within the .root selector at the very top of the style sheet. Centralizing color palettes and spacing tokens in .root acts as a lightweight, single source of truth architecture. Adjusting one value updates the entire theme. Setting up a framework configuration file for a prototype of this scale adds unnecessary friction. The native variable approach requires zero setup and compiles instantly in the browser. In the context of a self-contained prototype, the AI's rejection of CSS frameworks is a rational application of modern web standards. The highest fidelity visual component in the codebase is the profit-loss hero card, featuring a dynamic glass morphism glow. The rendering challenge here is generating a colored ambient glow that responds to state changes without bleeding over the rounded borders or obscuring the text content. This diagram shows the baseline DOM layers, a blurred background base on the bottom, the text layer suspended at the top, and an empty gap between them. To create the glow, the AI injects a pseudo-element into the gap, housing a dynamic radial gradient. Left alone, this gradient layer would slide under the page body. The AI prevents this using isolation isolate. This creates a new stacking context, forcing the browser to trap the pseudo-element C index strictly within the boundaries of the parent card. The AI pairs this with a layered box shadow technique. It combines a 1-pixel solid outline with a -12-pixel spread blur to create a contained neon rim. There is also a specific typographic detail. The AI uses font variant numeric tabular nums, forcing the financial digits to align perfectly in columns regardless of individual character width. By isolating the stacking context and enforcing tabular alignment, the AI utilizes the DOM's native rendering pipeline to handle visual complexity that would otherwise require heavy JavaScript logic. The precision of that CSS rendering ends when we reach the JavaScript block at the bottom of the monolithic file. Vibe coding struggles with state management over time. The AI defaults directly to procedural, linear scripts. The first major architectural flaw is global scope pollution. Critical state variables like transactions and chart data are exposed globally to every function in the file. A severe security vulnerability also exists in the rendering functions. The AI uses inner HTML with string interpolation to dynamically build the table rows. Injecting raw user input directly into the DOM via inner HTML opens the entire application to cross-site scripting attacks. But the most severe scaling issue is hidden in the algorithmic complexity of the charting logic. This diagram shows the data processing loop. To calculate the chart, the script iterates through every transaction for every day on the timeline. This is an order n² problem. With 500 days and 50 transactions, the browser computes 25,000 iterations for one render. A human engineer would immediately solve this by pre-calculating an index. The AI lacks the foresight to optimize nested loops for scale. The JavaScript execution is purely cosmetic. It successfully drives the visual interface on day one, but structurally collapses under the weight of real-world production data. This diagram plots the utility of the generated codebase on a spectrum of project scope. As a self-contained personal tool, the monolithic structure is efficient. For enterprise production, it is a liability. Bridging the gap between an AI prototype and production software requires specific human intervention. Preserve the AI's CSS architecture. Its use of custom properties, native grid layouts, and stacking contexts is more efficient than defaulting to bloated frameworks. However, the JavaScript architecture must be discarded. The necessary refactoring is clear. Extract the global variables into a state management module, secure the DOM injection points, and mathematically index all nested loops. The core skill in modern web development is acting as the architectural editor, knowing where the AI's utility ends and human engineering takes over.